Hey everyone, welcome to the live stream. I'm Alfred.
I'm Submarine.
And this is episode 112. And in this episode, we will be interviewing Alessandro Grande. And he's basically a developer advocate for ARM. So we'll do the interview with him, talk about a lot of really cool things that we're doing with ARM and that ARM is doing in general. And then we'll get to some announcements that we have afterwards. I'll intro out Alessandro. So basically, he's a developer advocate at ARM in the automation and IoT division. He's part of the global team that focuses on supporting a diverse range of developer ecosystems, building solutions in IoT, robotics, drones, AI, security, and automotive. He joined ARM as an electronic engineer back in 2014 after 4 years working on design validation as an engineer. He spent 6 months as an education specialist, supporting engineers across the globe with the right tools, support that they needed to help students pursue a career in electronics and computer science. And prior to joining ARM, he achieved a degree in nuclear and electronic physics, which I actually didn't know that prior to reading the bio, from the University of Rome, Italy. So yeah, without further ado, let's say hi to Alessandro.
Awesome. Hey, Alessandro.
Hey.
Hello, everyone. Hey.
How are you doing?
Excited to be here. Good, thank you. How are you guys?
Great. Yeah. Thank you for joining the stream. And it's funny, I've met you, what, 4 times now? 3 times?
Yeah.
And I had no idea that you had a degree in nuclear physics. That's amazing.
That's pretty cool.
That's really cool.
Yeah.
My other life, yeah.
Your other life. Also,
Secret.
the engineering education program, that is solid. I didn't know you did that either. But
Yeah, that was a 6-month project in which I supported a team to actually develop education resources for engineers. That was super cool, actually.
Very nice.
Very cool. Yeah, so I guess to intro it out, could you give our viewers an overview of what ARM is and what they do?
Sure. So for the ones of you that don't know, ARM is actually the biggest fabless semiconductor company. What I mean by that is actually we don't produce any microchip or any chip. What we do is actually partner up with our partners to produce the chips that we design and that we architect. So the best way to imagine and to see that is if you think of a house. That's the example I usually give. You have a builder that actually goes off and builds the house, but you have the architect that needs to put together the designs so that the house can be functional and that can meet the needs of the inhabitants, as well as making it energy efficient and making it as low cost as possible. So those are the things that we do on our side. So we try to make sure that we architect the best possible solution for then people to go off and build it.
Right.
Yeah.
Yeah.
And just so people know, there's the ARM architectures that you guys do, and then the other main one would be x86, which is typically used by Intel, by AMD for desktop processors. But a really cool thing about ARM is it's in basically every mobile device, just because it's so power efficient, right?
Yeah, I was gonna say. I mean, it's quite interesting because when you look at the numbers, it's quite it's just overwhelming. I mean, last year alone, together with our partners, we shipped 21. I gotta read it because I'm always confused about the actual number, but it's 21 billion. It's so big that it's really hard to remember. 21 billion devices together with our partners, and that means that if you think about the number of people in the world, it's basically 3 devices with ARM IP per person, and that's when you think of that, it's it's just overwhelming.
That's gigantic. Wow. And the number's only growing. I read last year that now there's server farms, Amazon is starting to use ARM chips within the servers instead of x86 because of the power efficiency that they're getting from it.
Yeah, there's been an announcement recently at Amazon reInvent where they've announced that actually they've got ARM CPUs now that you can use. You can actually pay for the ARM CPUs on the cloud, and obviously they're more energy efficient and more low cost. So it's just another solution that you can use as well on Amazon as well. It's yeah, it's really exciting actually.
Yeah, yeah. So I guess talking about like cool, exciting things, are there any interesting things cooking up at ARM right now?
Always loads. There is a lot of stuff that we are doing on our side. So as I mentioned, there is this massive number of CPUs and massive number of people using our intellectual property, our architecture, our designs. And what's interesting from my perspective is that all these different CPUs come with like a lot of different developers in a lot of different markets. So we have really all the markets that you can think of, all the applications you can think of. We have the ARM developers that are using our technology in those applications. So from my perspective, the question is, how do we support, how do we help all those developers to actually be more successful in what they're doing? So you guys know about it because you're part of it. We've launched last year the ARM Innovator Program, and this is a program where we aim to find the most innovative people around the world, the engineers around the world, and we try to showcase what they're doing so that way we can support the different communities throughout the work of the different innovators. And Rodolfo, so your CEO, he's actually our innovator, and he's an expert in ARM, in general in computing on the edge. And you guys are, I kind of think of you guys all as innovators because you're all doing all these amazing things. So it's it's great. And then there's a lot of technical announcements that happen all the time. Just today, there's been an announcement of a new architecture extension for Cortex-M microcontrollers. So that's really exciting. It's a really exciting new extension that will allow people to do more machine learning on the edge more efficiently. So that's it's early days in the sense that it's just the architecture extension, the architecture announcement. But as I said, with architecture comes the implementation afterwards, and I'm really excited to see what developers can actually build.
Right. Yeah, cool. It really seems like you all are trying to kind of bolster developers, help them get where they want. Because you recently also opened up the Cortex-M1 and M3 architectures on the FPGA, which is something we're itching to try out when we can figure out how to work our FPGA. But definitely seems like you're trying doing a lot to support developers out there. Yeah,
and just from being part of the ARM Innovator Program, I mean, we've gained so much from it. Just going to ARM TechCon, the Google Next conference, everything you guys are doing is spot on to help developers, and we really appreciate it.
Yeah.
That's great. Great to hear from you. No, it's really great. I mean, yeah, you guys were part of ARM DevDay as well. That was a big online event that we just run together. But yeah, you're right. There's a lot of stuff that we do to try and support the different developer communities. So you mentioned about the FPGA, Cortex-M1 and M3 available on FPGA, and that's actually completely free of charge. And the reason why we do that is because there's a lot of people that try stuff on FPGA and then might move to an actual ASIC or an actual custom SoC, and we want to give them the ability to actually do that and not have to change the tools and the infrastructure that they use to actually build that solution on the FPGA. So this way, we're kind of providing this uniform solution across our tools and tools and packages to actually support developers throughout the different stages of their design.
Right.
So that's the reason behind it, and I'm really excited because it's going to open up a lot more innovation and a lot more developments on FPGA that then will actually develop into something real products and real. You will find more products using M1s and M3 in the future, and I'm really excited to see what people can develop. Right?
Yeah. I mean, we really want to put, so the Matrix Creator already has a Cortex-M3 on it, but it also has a Xilinx FPGA. So we want to put either an M1 or an M3 onto the FPGA, just, you know, for fun and to say, oh, look, now we have two M3s on there.
Yeah, and I mean, by the way, this has happened last year sometime. I forgot exactly when the launch was, but there's been a lot of work into try and like getting all the tools and every you know, like tutorials and things so that developers can actually go off and use this stuff, because you know that's always the hardest part. It's actually making it easier for developers to actually use what they have in their hands, right? So we're actually doing a webinar next week with Xilinx, where we're gonna showcase what's available and how to use it. And I'm hoping that we can do some stuff together as well, so we can showcase how to use the Matrix Creator. But we also have some new innovators that haven't been announced yet that will be developing more stuff on Xilinx and showcasing how it's possible to actually do to actually develop solutions with an M1 and M3. So there's a lot of stuff coming out that's going to help developers to actually use Design Start on FPGA in an effective way.
Awesome. Yeah, we should definitely get in touch to see what we can do to further promote getting the architectures on FPGAs. Yeah, I'm sure our chief engineer, Andres, he would love to look into it. He'll do that on his free time.
Yeah. But excited about new innovators, actually, because we like connected with so many like cool people at ARM TechCon, like other innovators, and you know, we actually like collaborated or like, you know, interviewed some of them in our live streams from like
Robert from 96 Boards,
and then Kitty from the Garage, Microsoft. Yeah, so we kind of like talked to them and like, you know, connected with them, kind of got insight from their communities as well. So it was really fun to you know, have those connections. So I'm excited about the new innovators too.
Yeah, there's always going to be more and more coming out. I mean, I think, you know, the whole idea of this is like we are a community and we want to find together the best innovators that can help the rest of the community, right? So if you have any ideas, if you have anyone that you think, you know, should become an innovator, come tell us.
Right. And so, quick question, just for, you know, our viewers who might be interested in developing things. Like how do you, like what kind of criteria, or like what do you look for in an innovator, like things like that, you know, when people are, you know, kind of looking to be innovators and, you know, for people who are kind of looking,
That's a great question. So what we look for is really people that try and push the boundaries on what's possible in ARM, right? So it's like, it's not just about building a new product that is successful, it's also about like doing something that other people haven't done, or doing it in a more exemplary way, or in a way that can actually help the rest of the community, right? So
in an innovative way?
What was that? Sorry, I missed that.
In an innovative way?
In an innovative way, yeah. But also being clear, like in what you're doing. So it's you know, a lot of people do stuff but don't really write guides.
Right. Yeah.
So you know, one thing that we try to do is like have innovators that can explain to other developers how to do stuff and how to actually get stuff done, right? So
and we showed that just a couple weeks ago with ARM DevDay, the whole day of webinars, where like we gave a 2-hour webinar showing how to use the ARM microcontroller on the Matrix Creator to get sensor data and use Snips with it. And that was great. I mean, I think Louise just sent us the video of it, so we'll be sharing that. But just from like we've received emails from people and posts on our community that people loved it, and different videos from people showing us like, oh, they're at their office like setting this up, watching the webinar. So it was really good.
Yeah, and there were a bunch of other innovator workshops there too, like the mini nodes, and like there was one from 96 Boards.
And I believe Kwabina from OpenMV was there as well, right?
Yeah.
Yes. Yeah.
That's super cool.
Yeah. I mean, so we didn't. I mean, I'm not sure how many of the people that are watching now have been on DevDay. I hope everyone, but if you haven't, we are releasing all the videos from DevDay actually it should be next week, I believe, or you know, the week after at the latest. We are we're releasing all the videos from the workshop that you guys have done, from the other tutorials, but also the guides with the video. So not just the video, but like the written content of how actually to build the thing yourself. And there was a lot of stuff. I mean, the whole day was around machine learning and artificial intelligence, especially on edge devices. So there was a lot of interesting stuff from you guys working with Snips. Then there was, as you said, Kwabena doing, showing how his OpenMV can actually be used to do machine learning and image recognition on a Cortex-M7, so just a microcontroller. I think, it's always interesting. I think there's, as I said, like there's a lot of stuff that we do, and there's a lot of different spaces in which ARM technology can be found. But what I find really interesting lately, actually, is the shift towards more computing happening on the edge. Mm-hmm. And I mean, people talk about edge in different ways, and I think, for me, edge is really like the low power, low cost thing that's always on at the end of, it's somewhere hidden that you don't even see most of the times. Yeah. And how do you make those things smarter? Like, how cool would it be if we could make those really tiny sensors, really tiny devices that are really cheap to install everywhere, really smart, so that they wouldn't have to send information to the cloud. They wouldn't have to they would just become useful by themselves, right? So and then after that, it's also like, well, what if we combine all these devices together to actually create this smart ecosystem of devices? And I think there's a lot of stuff happening in that space, and that's what we tried to showcase again with you guys and Snips, and with Kwabena doing his work on the camera, and using. So as ARM, we provide a lot of different tools, but some tools are actually to optimize machine learning on edge devices, especially on Cortex microcontrollers. Cortex-M devices. So I think that, to me, that's a really exciting space, and I'm excited to see what else comes out in that space, because I think that's huge.
Yeah, it's a lot cooler to have like little devices everywhere that they still may be connected to the internet, but they're all doing the processing on board. It's much harder, but like cooler to have it doing that rather than some huge server farm somewhere absorbing all the data and then spitting out the info. Plus, like the privacy concerns with that. Like if all the data and all the processing is happening locally, then you're not giving Google anything. So it really solves a lot of problems with it. It's cool. And now with 5G coming up, it'll make data transfer faster, but it's going to take a little bit to get there. So if we had edge computing before then, that's just sending low bandwidth amount of data to the cloud just for aggregation, it advances things much faster.
Absolutely. I think it's also, I mean, you mentioned privacy, security. I think it's interesting because the more stuff you shift around, the more chances there are that someone might sit, in the middle between those communications and actually get your data, right? So if you can keep it on the device, it's definitely more secure, right? And the other thing is also like, it takes a lot of energy actually to shift all this data around, right? So every time you try to use the cloud, you're actually not just using the cloud, but you're also shifting the information back and forth, and it requires energy, right? So if you could just operate on that information locally and come out with the result locally, then maybe you can shift that to the cloud, but that requires less information traveling on the cloud, to the cloud and backwards to the device. So yeah, I can see that as a more scalable solution. I mean, if you think about trillions of devices out there that are going to be smarter, there's no way you can shift all that data around, and there's no way you can shift all that data to a cloud server somewhere. There's no, physically it's impossible to think of a cloud that can operate on all that data, right? So there's going to have to be more machine learning happening on the edge, and and it's really exciting space, I think.
Yeah, and on top of that, it further democratizes it, because like right now, in order to have a system in the cloud that is able to absorb all this data and process it, you have to be Google or Amazon, Microsoft, IBM, whatever. But if it's just a lot of small devices that it's easier for people to buy, they have a lot more options, then it makes room for smaller companies to come up and actually make products that people can use in this space, rather than it just being, you know, these huge companies doing it.
I like that. I mean, and on that, there was during DevDay actually we announced W600. It's a new board that Seed has produced, and that's again, that's like, it kind of goes into, it ties to what you were saying, right? So it's a board that costs a few bucks, and it's capable of doing stuff that you couldn't possibly do on a computer 10 years ago. Yeah. So it's like, it's really democratizing the shift towards, like, you know, making stuff cheaper and making it more available for developers to actually try out things and come out with solutions that could actually be efficient and be effective. I think it's a really interesting shift, and I think it's going to open up to more innovation, and you're right.
Yeah. So here, let me see the questions we have here. Yeah, which, by the way, anybody in that's viewing in the chat, if you have questions, post on there. I'm looking on the chat. I'm posting links to things that we're talking about as well. But let me see, what else?
Looks like we covered a lot, and like very quickly, which honestly, like, you're the best interviewee with time so far. Like, you know, you're very, like, what do you call that? Like, concise and to the point with your answers. It's awesome. Great, yeah.
That's how I also speak very fast usually.
Well, it's been good, yeah. But there's one question that we didn't ask that kind of, I guess, goes back, but kind of like your backstory to how you came to be at ARM, and sort of how you've kind of, like, seen the developer community there grow. But I don't know if, like, probably a lot of things have already covered there, but, you know, I don't know if you have any more to add to that.
Yeah, I mean, so it is interesting because I guess, yeah, it's interesting to talk about it because it's my story is not really a typical story. You mentioned that I did physics, and I think that's interesting, right? Not because I'm interesting because I did physics, but because actually I didn't go through the normal path of, like, you know, being an engineer, well, studying engineering and then getting into ARM, right? So I did study nuclear physics, and while I was doing that, I did a thesis project that was actually using a Xilinx FPGA at Sync. And on that, there was on the SoC there was obviously ARM, an ARM A9 core, and I started using the ARM A9, and I remember, like, thinking, you know, this is really interesting. I want to know more about this. And then I found out that ARM was hiring graduates at the time, so I was like, oh, let's see if I can actually, you know, have a possibility of getting a job as an engineer, even though I've not studied to be an engineer, right? Yeah. So I did. So what I did was I applied to the graduate program, and I entered as a graduate that year, and then started working as an engineer. So yeah, so that's a bit, you know, it's a bit like a winded road to getting into ARM, because I wasn't, that wasn't the plan to start with, because actually I was doing physics, right? Yeah. So, but I'm really happy to be here, and it's really exciting. And then I guess I've started looking at what developers have been doing, and what developers, all the stuff that we put out there, right? There's a lot of people using it. So I've become more and more interested in looking at what's happening in the developer community, and what's happening around how people use our technology, and how, you know, it's really exciting to see all the different applications and all the different cases in which developers come up with, like, all these great ideas, and they really change the world in some cases, right? And that's how I got into this new role. And you know, you said, how did you see, the question was, how did you see the developer community grow or evolve? And I guess, you know, I mentioned how many chips are being shipped every year. So it's really exciting, because you always see more and more developers starting to use ARM, right? Yeah. And more developers asking questions, more developers trying to figure out what they can do with ARM, what they can do with ARM IP. And I think, you know, the shift towards putting more stuff in the hands of developers is actually something that's going to see that increase, right? So it's going to see a lot more developers use our technology. And yeah, I think so. The growth in the developer community is massive, is really exponential. Like, every year, you know, we see more and more developers. And this is why we can't really, you know, talk to developers by ourselves. This is why we need people like you guys that are awesome at what you're doing. I can share, your vision and your technicality, your technical skills, your platforms to actually help developers with what they want to do.
Right.
Yeah. And in the end, I mean, we're all developers ourselves, and we made like our products because like we see these niches, these problems in the developer community that we're like, oh, why do we have to spend hours trying to wire together one thing and then a week trying to get it to work? Just make one board, has it all the libraries are there, it works, has an ARM microcontroller, and it helps people. And so it's, it's developers helping developers helping developers. It's just developers everywhere. And so we've spoken a lot about like the IoT side of it, but in your bio it also says that you work on automotive as well. So I don't know, what could you talk about what's happening there in that space?
Yeah, so in general, there's a lot of stuff. You probably heard a lot of stuff happening. A lot of companies, a lot of startups looking at how they can develop the new autonomous car, right? So everybody's trying to develop autonomous cars right now, and it will be the future. I mean, it will happen, right? So it's not a question of if it will happen; it's a question of when, right?
Yeah.
And what we see from a developer perspective is actually there's a lot of interest in developing autonomous vehicles that are obviously smaller. In some cases, well, there's different situations, but in some cases they're smaller than what you would expect, than a full-blown vehicle. Like for example, I don't know if you guys are aware if you know the community DIY robocars. Mm-hmm, so they're an American community. And one of our innovators, Will Roscoe, he's the co-founder of Donkey Car. So this is the platform that you can use to actually build one of those cars that then you can race in the DIY Robocars events, right? Yeah. So that's a really interesting community of developers trying to come up with solutions for problems that are really, really big problems, right? I mean, autonomous vehicles are not there. Like, we're not there yet. It's not a built thing. And I think there is a lot of interesting stuff happening at all different levels. And we're trying to see what can we do to help those communities as well. Those communities of developers like the DIY Robocars communities to actually come up with better solution, with more interesting solutions. So we're working with the rest of the business to actually see if there is anything that we can provide to these communities to be more successful and actually do something that's more scalable as well. So work in progress. You'll see more stuff coming out.
Okay.
So it's exciting. I mean, there is a lot of innovation happening in that space. It's a really new market, and it's a really new set of problems. One thing that we feel like we are strong on the security side of our processors and of our applications. And we were talking about machine learning on the edge before, right? Mm-hmm. And we gave a couple of reasons as to why that's important, or that the reasons why we think it's important. And I think there is another one in the automotive space actually that's really key to. Another reason why you should really think about machine learning on the edge, and that's if you think about a car that's connected to the internet, you also want it to be driving reliably if it's autonomous, right? So you want to make sure that if it is connected to the internet and it is communicating to the cloud, it will still be able to brake if you need to brake, right? So you might want your systems to be smart enough so that you can still brake in the case of some problems with the connection to the internet and stuff like that. So that's why we think we can really, really help, because we are doing that on embedded devices. We're doing that in a lot of different spaces like IoT, for example. So we think a lot of that work can actually be reused and rethought of for automotive.
Yeah, and with automotive, again, another advantage of having all the processing on the edge is security. I mean, if you have these huge fleets of autonomous cars and you're somehow able to hack in and control them, I mean, you could wreak havoc, or you could. I saw one video. I like Elon Musk, so I saw one video of him answering this question about Tesla specifically, and he was like, "Yeah, that's like Tesla's a huge focus for them because if that ever happened to them, like, you know, Tesla would be out of business immediately. So having all the processing on there and then just creating the security layers on top of that to make sure that, you know, everything's safe from any anybody potentially trying to do anything. You know, it's much better.
Yeah, and then also like kind of like what you said about how they should the chips would communicate with each other and have this kind of ecosystem or a network. You know, instead of like, you know, maybe they have like a direct communication with each other rather than to the cloud and then to a different device. Like, you know, when all cars become autonomous in the future, maybe not so far away, like that kind of communication to keep everybody in their lanes, to keep everybody like in the right space relative to other cars, like that kind of stuff would also be like super important. You know, because like, I don't know, there's a name for it, like when it's like you are keeping yourself in position relative to other cars around you, right? I don't know, I forgot the name for it, but...
No, absolutely. I think communication, I mean, when you think of smart devices and, you know, computing on the edge, typically you kind of like think of the two extremes, like either everything on the cloud or everything on the edge. Yeah. But there's a lot of like intermediary scenarios where you could have, for example, really tiny devices that are doing like some computing, and then you might have a gateway to which these devices are connected that actually is doing some more computing. Right. So you could have like a hierarchy of computing happening at different levels, and most of it is still happening on the edge, because I mean a gateway is still to some extent, you know, an edge device, right? It's a device that's in that case connected to the cloud. It could be connected to the cloud, but it's still a device that's doing a lot of computation without having to shift data back and forth to the cloud, right? And alongside with that, you also have situations where you might have some computation done on the edge and some computation done on the cloud. So you could share the load of like, you know, what's worth doing on one side and what's worth doing on the other side. Yeah. And that also helps when you want to update. So if you want to update the firmware on the device, you might actually not want to update the whole model, but you might just want to update a little bit of it. Right, so you might decide that actually you're going to split the model in two and do some neural network processing on the cloud and some neural network processing on the edge. So there's a lot of different ways in which you could tackle the problem of computation on the edge. And I think, yeah, I mean, it's interesting because basically the edge devices become more independent and they can operate on their own without having to rely always on the edge, right? And I think that's, on the cloud. And that's, I think, the interesting bit. And then you can, you know, split that computation as much as you want.
Yeah. And that split, I mean, it's what like Amazon and Google do with their like assistant devices, like an Amazon Echo. It does the wake word on the device, and then once it hears the wake word, it starts streaming to the cloud to do the processing. Of course, that's more cloud-oriented, but maybe in the future we'll see everything happening on the device.
Yeah, I mean, Snips is a good example of that, right? Snips does most of the stuff. Well, it does everything on the device.
Yeah.
Yeah. Like you don't need the internet necessarily once you have everything, the system downloaded.
Yeah, like, you use the internet in order to update it. That's it.
That's it.
Exactly.
So it's pretty nice. Yeah. Well, I think like, you know, it's pretty good. We covered most things.
Yeah.
Do you have like anything else you want to share with our viewers?
I was looking at the question. I think there's a question. On the chat.
Yeah, I had to scroll. Okay. Yeah, so here, I'll read out the question. So, what is this? Pyjama says, interesting about nuclear physics, is AI being used in that field?
I mean, this is I guess a general question. Yeah. There's AI means a lot of different things. So, the interesting, I guess, from my perspective, when I was doing, when I was at university, I was looking at a lot of different applications of machine learning. One of the typical things, for example, is if you have a detector, you guys probably know about, like, you know, these massive accelerators where you get particles to crash against each other, and they generate all these other particles that you're trying to study, right? The interesting thing there is that you have a lot of data, and in most cases, the data is really, really complicated because of the amount of it. Right, so you have a lot of like interaction happening during a certain period of time, and you have all these what were they called now? It's been a while actually. But you have all these signs basically of all the different particles in the detector, right? So the detector is telling you what kind of things it's seeing, and what you want to do, what you want to use machine learning for in that case is to try and understand what particle it was. So you have like the detector is telling you, oh, I've seen something. This is the energy, or this is the velocity, or this is the angle at which it turned, or whatever. And then you want to connect that to the actual particle it was. And that, in most cases, because you have so much data, you actually do machine learning. You use machine learning algorithms to actually come up with the right solution quickly. So yeah, so there is a lot of cases in which machine learning is actually used massively in nuclear physics.
Yeah, and on that, just a couple of weeks ago, I think The Verge released a video that I saw that was basically they went to a company that is working on a fusion reactor for like energy, like the type of energy that the sun produces. And they're using machine learning in order to adjust all of the ridiculous amount of variables that they can adjust in order to achieve the best result for the fusion reaction. So that's just how they're using it. It's less about like absorbing. Well, the machine learning is seeing the data from the results and then tweaking the variables for them, or giving them several options to tweak so that they can just advance that much faster than if they themselves had to sort through all the data and then figure out, okay, well maybe this variable changing that will help it. So it's just
interesting.
Yeah, basically using machine learning to help us rather than it doing everything on its own. It's supplementing us, and we're using the knowledge we gain from it to then make decisions. Just like doctors using it, they may get like, I don't know, a machine learning algorithm can see hundreds of thousands of X-ray scans. You feed it the scan of your patient, it tells you something, and then the doctor can make the actual like diagnosis and prescription and so on. So I think that's like a good future for machine learning. It's not taking over, but it's rather it's an added layer of cognition for us.
Yeah, I feel like it's a bit dangerous to have a takeover for sure, because like for outliers, it would be difficult if there was no human kind of checking. Yeah, there's no general AI yet. Yeah. Or ever. Who knows? Maybe some ARM chip.
We'll see.
Yeah. Cool.
Right.
So let me see if there's anything else. Lewis says, greetings from Venezuela. Nice.
Nice.
Wow. I hope you're doing well there. Some of our team members are Venezuelan, so they tell me all the time about what's happening there. Let's see. Oh, Pajama asks, ARM for training. So I imagine referring to like training of machine learning algorithms. Any thoughts on that?
I mean, there's a lot of frameworks that are out there for training machine learning algorithms, so models actually, machine learning models. And what we do is actually have SDKs that interact with all these frameworks. So they allow you to connect the framework, the model that you generate from the framework, and deploy it on a board of your choice. So we actually provide what's called ARM-NN, and this is it's an SDK that allows you to basically port your models to an actual hardware. So that's kind of that's as far as we go right now. So we are actually interacting with all these frameworks and allowing you to use any of the framework that you want, because then we are enabling you to port it to the board, to port the model to the board.
Yeah. Cool. So I guess if anybody else has a question, please put it in the chat now.
Or forever hold your silence.
Yeah.
Or no, you can post in the YouTube comments as well. And,
but I guess Alessandro, do you have anything else to say? Anything to plug?
No, I think we've covered most things. I was going to just remind everyone that we are going to have this webinar with Xilinx next week. If you're interested in knowing more about design start and Cortex-M1 and Cortex-M3 on FPGA, how you can get started with that. And as we mentioned before, it's all free of charge. So actually, just a webinar, but actually using Cortex-M1 and Cortex-M3. So if you want to know more about how to use them and what you can do with them, join the webinar. There is a link in the chat already.
Yeah.
The other thing I was going to mention is the fact that we're going to release all these videos from ARM DevDay, one of which is actually your tutorial. So it's a 2-hour video on how to use Matrix Labs, or Matrix Creator, sorry, and Snips. So stay tuned. We're going to release this shortly. And to find out more about when this will be released, you can either, should I post something on the chat, or could you post?
Feel free.
Sure. Or,
or maybe you could do it.
Yeah,
so you can, so basically, we've got arm.com/innovation. So this is our community basically, where we share all the information around what the innovators are doing, what other stuff is coming out, what new content is coming out from the innovators, and we'll be posting the new recordings on that website. Okay. The other thing is, if you want to follow me on Twitter, I'm Alessandro Devs, and I'll be posting about stuff when it comes out as well. So if you like Twitter, that's another way of getting the information. Yes, I think that's everything.
Cool. Okay. So one person did ask one final question from Lewis. I want to know if you could talk a little bit about Pelion. So, and I Googled it for a second. It's like an IoT platform that you guys have.
Yes. So Pelion, I have to be honest, Pelion is not really something that I'm really involved into, but I know a little bit about it. I can share with you what I know, and then feel free to ask me more questions if you're interested. If you got some specific interest, who was it, Louis? Yeah, Louis. If you got some specific interest, feel free to reach out, and I can connect you to the right people. But what it is basically it's a framework to enable you to interact with devices on the edge. So it's something that sits in between the cloud and the edge device. So, for example, provisioning of the device or firmware updates and stuff like that. This is basically a way of doing that by using our technology. Or, sorry, I should say, it's a way of doing that on our technology. And it's part of the wider embed space and embed environment.
Okay, cool.
Nice. All right.
Well, I guess I don't see any other questions in the chat, so I guess we'll end it off. Thank you, Alessandro.
Thank you very much.
Great talking to you, and yeah, we'll chat later.
Thank you, guys. Thank you so much for having me, and have a great day.
Yeah,
awesome.
Thank you. You too. Bye.
Bye-bye.
Bye.
Let's see.
Okay.
Cool. Awesome. Let's switch over to this camera.
Hello.
That was great.
Yeah, wow. That was a lot of great information. And I was just like, wow, like I haven't thought about that kind of stuff in a while. Like the like machine learning, like and also like they have so many resources for developers.
Oh yeah, that's amazing. I mean, what ARM is doing for developers, like I don't know of any other big chip company that really does anything for developers. Like Intel doesn't, AMD doesn't, NVIDIA kinda, like with the Jetson, but like ARM seems to be like doing the biggest push for developers and making it open for really anyone to just develop with their architectures and make things with it. And I mean, it's enabling so many people, like all the innovators in the Innovator Program, ourselves, with our boards.
Honestly,
it's making a big difference.
I really want to sign up for that Xilinx. I probably will sign up
for
that
Xilinx webinar. As will I.
Because I'm like, okay, I don't know a lot about FPGAs, but I want to learn. So, like, I think that would be really fun.
Yeah. So and it's really cool. Like, I mean, ARM is everywhere, right? Like, it's from my Apple Watch to every smartphone, I guess, except some, like, Samsung ones with a different chip, but so like the Raspberry Pi, our board, it's just amazing where everywhere ARM is.
This one right here.
And so them with the developer community, it's really spreading it even more. It's really cool to see, and they're amazing to work with. Alessandro's amazing, Louise, Rex, like the whole team. They're really great.
Yeah. All right.
Cool.
So you want to move on to some announcements?
Yeah. Right. So announcement. I guess this is a good transition. So we were I'm going to talk about the Snips contest. So,
Yeah.
in sometime in April, we've already touched on this a little bit, but we are going to be doing a contest on Haxer with Snips and ARM. So we're still working out the details of the contest, but it'll be sometime in April, so stay tuned for that. We'll be posting things on our Twitter, our Facebook, so on, so make sure you're following us there.
Super excited about that.
Second part is last week we did a live stream showing you how to use Snips, a Matrix voice, or any Matrix device to control your lights using a relay. And we did a whole video showing you how to do that, and we posted the guide on Haxter, so you can see it here. I always forget which camera we're on.
Yeah, this one.
This one. So here's the guide. It's already out. It has, what, 780 views already in like a week.
Amazing.
Awesome. Yeah, so check it out. It's a really good guide. It has the video there of the live stream we did last week, and it basically goes through the code of how to use MQTT to get the Snips commands, like if it hears, well, here we have one set up in the office, so, hey Snips, turn off the light. Will it work? Yes!
As you can see, we are now in the dark.
Yes, so I'll turn it back on. Hey Snips! Hey Snips! Hey Snips!
Oh no.
I don't know what happened to it.
It's super far away.
I was messing with it. I shouldn't have been messing with it for the live stream.
It's okay.
Hey Snips! Turn on the lights.
Yay.
It's also like 15 feet away from us.
Yes.
So, and it's underneath the air conditioner.
Yeah. So
but yeah, I was messing. I was
good.
messing with it beforehand, so no worries. But yeah, you can check out the guide. Shows you how to use the Snips console to set up Snips. Use the MQTT commands to make the lights on it react when it hears the wake word, and then do actions like with the GPIOs on the Matrix voice in order to activate the relay, disable the relay to turn on and off your lights.
Yeah.
And that could be applied to so many things. We have some guides in mind. One of them is doing a thermostat with it, because in the end a thermostat it's basically just connecting a wire, like the power, to the air conditioner when you want it running and turning it off when you don't, and then it has a temperature sensor, so stay tuned for that guide sometime.
Also, FYI, Alfred designed this beautiful case, so this is one of our guides that has a 3D print STL file attached to it if you want to print a case to go on your wall as well, so definitely check it out.
Yeah.
All right.
It's a cool case.
Yeah. Definitely looks nice.
Yeah. And then the next one is our Matrix kits. So if you want to quickly and easily start developing with the Matrix Creator or Matrix Voice, we've made these kits for you. So in the kits, it comes in a really nice box, has a Matrix Creator or Matrix Voice, a Raspberry Pi 3B Plus, the latest one, a power supply, and then an SD card already pre-flashed with Raspbian and all of our libraries. So you can just buy the kit, plug it in, and it works, and you can start programming it immediately. So you can get these kits on our website, either store.matrix.one or visit our educators page, because we're really pushing this for education, whether you're a student, a professor, a lab manager. It makes it a lot easier to start working with all the sensors on our devices, with the ARM microcontroller, the Xilinx FPGA, the Raspberry Pi, and so on. And we've seen a lot of universities buying these lately, and it's really good.
Yeah, so definitely check out the kits. We will move back to our camera so you can see us.
And then if you have any other questions, post them in the chat now. There's like a 10-ish second delay. So yeah, with that, if nobody has anything, let me make sure on our Slack if anybody's told us anything. Nope.
Yeah.
Okay.
Well, cool. You can post it on the YouTube comments if you have questions. If you have technical questions or need some advice on some project, please post on our community. That's community.matrix.one, also in our description. Yep.
And follow us on Twitter at @matrix_creator. Right? Yeah. Or Facebook, Matrix Creator. Yeah. And yeah, so with that, there's no questions. So I guess we'll be signing out.
Awesome.
Again, this was Alfred.
Sumrine.
And thanks for watching. Bye.
Bye.